It's kind of funny when you stop and think about it. You're having a constant conversation with your phone, your laptop, your tablet, all day, every day. It's this silent, super fast back and forth that we totally take for granted. So today, we're going to pull back the curtain on that everyday magic. We're going to look at how our computers talk, and maybe more importantly, how they listen. And let's kick things off with a little fact that might just change how you look at your screen.
Okay, get this. The average person blinks about 20 times a minute. But when you're staring at a computer screen, that number plummets to just 7. That's it. We get so locked into this digital conversation that we literally forget to blink. That's just how engrossed we are.
Because at its heart, that's what this all is, a conversation. Think about it like this. Input is you talking. It's you telling the computer what to do. And output, that's the computer talking back, showing you what it did. All the devices we're about to talk about, they're just the translators that make this whole dialogue possible.
So let's start with our side of the conversation. Input. How do we get an idea out of our head and turn it into a language that a machine can actually understand?
So, how do we kick things off? Well, for most of us, the answer is, quite literally, right at our fingertips. We usually start talking with our hands.
The keyboard is, for sure, our main voice for text. It's the most direct way we have to just spell things out. And if you look at it, it's kind of like it's broken down into different neighborhoods, right? You've got the function keys for shortcuts, the navigation keys for moving around, and that numeric keypad for when you're crunching numbers. Each little section has its own job in shaping what we want to say.
But we don't just talk with words, do we? A huge part of how we communicate is nonverbal. It's all about pointing, gesturing, and just directly moving things around.
These are all basically different dialects of the same language. Hey cursor, go over there. The classic mouse just translates your hand's movement across the desk. A trackball kind of flips that on its head. You move the ball and the device stays put. A touchpad, well, it reads the slide of your finger. And that little pointing stick is like a tiny, pressure-sensitive joystick. All different ways to say the same thing.
And pointing has gone way beyond just moving a cursor. I mean, we've got touch screens at ATMs and info kiosks that let us interact directly. Our phones took that to a whole new level with multi-touch. That pinch to zoom you do without thinking, that's a pretty complex gesture that the computer gets instantly. And of course, for more specialized talks, artists use a stylus for precision, and gamers use a joystick to really get in the game.
But the conversation isn't just limited to what we can do with our hands. To really get what's going on in our world, computers have started to develop their own senses, starting with sight and sound.
Scanners are basically the computer's eyes. Their whole job is to turn physical stuff into digital data. A flatbed scanner can read a photo or a document, and believe it or not, that's the same basic tech at work when a card reader sees the data on your credit card's magnetic stripe.
All right, so we've done a lot of talking. Now it's the computer's turn. Let's flip the script and look at the other side of this dialogue. Output. How does all that digital stuff get turned back into something our human brains can actually understand?
Everything, and I mean everything you see on a screen, starts right here with the humble pixel. It's like the atom of a digital image. It's just one tiny dot of light that can be any color. By itself, it's nothing. But when you get millions of them working together, that's when you get every letter, every icon, every video you see.
And it's a really simple formula. The more pixels you can pack into a screen, that's what we call resolution, the sharper and more detailed the picture gets. It's the difference between a blurry, fuzzy image and one that looks stunningly real.
Now, when the computer needs to talk on paper, it usually uses one of two main methods. You can think of an inkjet printer like a microscopic spray painter, just shooting these teeny tiny dots of ink to make the image. A laser printer, on the other hand, is a lot more like a photocopier. It uses static electricity and a fine powder called toner, and then it uses heat to fuse that toner right onto the paper.
And of course, the computer's voice isn't just visual. Audio output devices, like your speakers or headset, they're the ones that translate digital signals into the sound waves we hear as music or notifications or a friend's voice. Your old iPod? A perfect example of a device built almost entirely for this one kind of output.
But here's where things get really interesting in the modern world. That line between input and output, it's getting really, really blurry. A lot of our devices today are designed to make this conversation feel less like we're taking turns and more like a totally seamless, real-time flow.
Just think about it for a second. Your phone's touchscreen is the perfect example. It's an output device, right? It shows you stuff. But it's also an input device because it's capturing your touch. That big all-in-one printer at the office can output a printed page, but it can also take one as input by scanning it. And a service like Skype is doing both all the time. It's capturing your voice as input while delivering your friend's voice as output simultaneously.
So why does any of this actually matter? I mean, who cares how it works, as long as it works? Well, it matters because understanding this basic conversation is about way more than just tech specs. It has huge implications in the real world.
Let's just take this question. It's a great one. At first glance, you might not think it's that important, but in a super high-stakes place like a hospital, knowing your hardware isn't just some nice-to-have skill, it can be absolutely critical.
So imagine a doctor needs to get a patient's electronic health record, and they need it now. In that moment, knowing how to use an input device like a smart card reader isn't a tech problem, it's a patient care problem. Any delay, any little error, that could have really serious consequences. Speed and accuracy are everything.
And that's just one example. This human-computer conversation is basically the engine that runs our modern world. It's in the ATM you use, the self-checkout at the grocery store, and the phone that's probably in your pocket right now. You can't escape it. It's everywhere.
Which really just leaves us with one last and I think fascinating question to chew on. We've gone from keyboards to mice to touchscreens to just using our voice. As this technology gets smarter and woven even deeper into our lives, what's next? What is our conversation with our machines going to look like tomorrow?